We are getting ready to test the well water in this well here at UW Green Bay. And so we are getting our equipment ready. We have a water level meter here that measures the depth of the well. We have our sample bottles, and we have some sterilized bottles here so we can do some E. coli testing. And we have these disposable balers here. There are about 1 liter in each of those. So we're gonna get ready.
Here we are, we're at UWGB. They have several groundwater monitoring wells. And today we're going to demonstrate how to measure down to determine what the level of the groundwater table is at this site. As well, then we're going to bale the well in preparation of recovering a sample, a groundwater sample. So the first thing we do is we determine how much water is in this well. Technically, the water that is standing in this well is not groundwater. It's technically surface water because it's in contact with the atmosphere. And what we'll need to do is use one of these balers I'll show, or other types of balers, and bale out the surface water portion. And the DNR guidance indicates we need to bale 4 volumes of the water, that's standing water in this well, in order to be sure to move groundwater into the monitoring well, and then we'll recover our sample. This is just some information on this well. Let's see that. Oh, okay, is that good? Mm-hmm. And we're at the piezometer well here. Okay, so it's drilled to a 42-foot depth. You'll see on the reverse side it goes down to bedrock. And this gives just some general information. The well is 3 foot. The metal is 3 feet above the groundwater level, and then goes down to a total depth of 42 feet. On this side is the geologic formations that the well is drilled through, and we see quite a bit of clay, and I suspect that we are in a perched water table, meaning the clay is preventing any of the rainwater that infiltrates down to the ground from reaching the bottom aquifer at the bedrock level. So I think we're in a perched groundwater situation, but this was determined during drilling or augering of that well. So let me demonstrate our level instrument. So here's our level measuring instrument. It's got some batteries. You can see on this side we have some batteries. We also have an electrical probe. So once this part of the probe, right in the middle there, once that reaches the water, you'll hear the beep. So that it's as simple as measuring down on this tape. So let me open up the well. And what we see here is that there's an outer casing where the 2-inch PVC well was inserted. What comes with this piece of equipment is a little device to assist in positioning this level indicator, and it's intended to be inserted on the metal wall casing here. And it looks like we're just not going to be able to fit this on there, but in general it sits off the edge of the metal casing, and we won't be able to get it all the way down here. Maybe we'll get it to work. Okay. And then we have a device, just a couple of holes here. You see that this gets inserted into the, yeah, it's not going to hold because we're not on the metal. But in general then what we do is we then string our tape right over this. If I can do it here. Right over this little guide. And then that helps us hold this in place as we lower. And there's some actual measurements then. You measure then at this point and it tells you, for example, to add 0.2 feet because we're actually above the top of the well casing. But we won't need to use this. It's intended to prevent the tape from hitting this metal casing and damaging the tape. Okay, but I just wanted to show you that device. We'll pull this back out, and in our case I'm just going to lower this right down using the just the tape itself. Okay, so you can set this and we'll lower the tape down. Okay, we do know it's a 42-foot deep well, and as I lower this, it should give us a little bell. Oh, I should mention first. I'm sorry. We don't know necessarily what is in this well. So as I open this well top, if this could be a hazardous waste site, first thing we want to do is we want to measure for any volatile organics. Just to see that this is a safe environment. If we need any additional personal protection equipment, I did not bring a meter with me, but we would measure the VOC. I know this is not a hazardous waste site. What we would also do, because we're going to also take some fecal coliform and E. coli testing of this water, is I would disinfect this probe because we do not want to introduce any biology into that groundwater that would give us a false positive hit on the E. coli. So once we've done that, I'll lower this down and you'll hear the beep and we'll take a reading. Feet, 6 feet, 7 feet, 8 feet. Okay. This just tests our battery. Okay, we're good. Oh, there we got a hit. So let me pull that up. So it's about 11 feet, maybe 1 inch, 1.5. I'm sorry, 11.15 feet. This is in tenths. So let me write that down. Okay. And then I'll demonstrate how we calculate. Oh, that worked. You can see that little guide is helpful. But let me pull this up here quick. And it's still wet, so pull that off this way. And what was that, 11.15 feet? So let me just show you that calculation. How much water is sitting in that well? Again, not technically surface water, or not technically groundwater, but surface water. And we know it's a 42-foot deep well, and the airspace above was about 11.2 feet, and so we have 30.8 feet of standing water in that well. I know it's a 2-inch diameter well casing, so we need to calculate then what is the volume of water sitting in that well. Here's our water level. And we want to determine what volume is sitting in this 2-inch diameter. So I think I've got my calculator. We'll do it in cubic feet. 2 inches is 0.17 feet. So pi d squared over 4 would be the area, and then times the depth would give us the volume, height, whatever. D squared, so we have the 0.17 squared over 4. This is feet squared, and then 30.8 feet. So in cubic feet, we have pi times 4 divided, and then 30.8 feet. So we have about 0.70 feet cubed of volume of water sitting in that well. And we have to purge at least 4 of these volumes. So we want to purge 4 times 0.70, and that would give us 2.8 feet cubed. Okay. Now with us we have our baler, and I'll show you this a little bit more. This is a sterile baler. You see it's in a plastic tube, so we don't want to introduce again anything into the groundwater that we might be sampling. I know this baler has a 1 liter volume. So how many times do we have to bail it? Actually quite a few in this case. But I do know that 1 liter, that there's 3.785 liters per gallon. And then I know it's 7.48 gallons per cubic foot. So this is liters. So how many liters do we have? 2.8 feet is the same as 79 liters. So technically we would have to take, if this were our method of bailing, we would have to evacuate 79 of these bales before we recovered a sample. What generally, if you're doing a lot of groundwater sampling, you'd basically lower a pump in, a submersible pump, and let that do the bailing. But I'll demonstrate the use of the bailing and how to recover the sample. So let me get that ready. So I have the baler ready, and I'll show you the baler. Again, it's a 1 liter volume, and on the bottom here you'll see just a little check, or a little ball, and that ball, when you lower the baler into the water, the ball allows water to come into your baler. Then as you pull it up, that little ball seats on the bottom. It's called a foot valve. Now, if this were a hazardous waste site, of course I would be wearing personal protection equipment, determined on what type of waste you think is present here. At the minimum, I would likely just have our safety gloves on. But I do know that this is not at all a health hazard here. So as I mentioned, we need about 79, maybe 80 of these bales, but I'll demonstrate just a couple of times how this baling works. What we would also do is, if this were a hazardous waste site, anything coming out of this, we would recover that. Even the water that we would bail would be recovered in a whatever 5-gallon drums or larger container for disposal. We wouldn't be able to put here. Of course, I know this is not a hazardous waste site. I'm going to dispose of our baling water just out here on the grass. But it would be important to recover that water, because at this point, you know, if you're coming up to a well that you're not familiar with, you don't know what's in that well, and you don't want to be introducing those contaminants here onto the surface. So I'll just show you this. Put this down. Okay, it hit the water.
How do you know it hit the water?
Yeah, I heard a splash.
You heard a splash?
Yeah.
Okay, you don't feel it when you're lowering it down.
A little bit I did.
A little bit of feel?
Hey, it's a little heavy. We got it full.
And you're just using fishing wire right here. Fishing string?
Yep. Pull this up.
Some fishing string for large fish. But that's full all the way to the tippy top there, isn't it?
Yeah, so this is 1 liter. And I would do, well, I don't have a bucket here to remove this. We would bale this then, like I said, 80 times, but if that were the case, I'm sure we would find a different way of baling, so that your client isn't paying you to sit here and bale all day long. So what we're going to do and do back in the lab is we're going to recover some samples. So, you know, assuming that this has been baled properly, we're going to recover some samples. One test we're going to do is an E. coli test to see if there's any pathogenic or potential pathogenic contamination of the groundwater, and that is done. That sample is recovered in a sterilized sampler. We're going to run a variety of other tests, and for those I've got just a standard plastic jug, a sample bottle, and we'll recover a sample for that as well. So we'll recover these samples. Again, after 80 times, we're finally sure we've got groundwater coming into our monitoring well. We get a little bit E. coli. Maybe we should have pulled it for this one first, right? To have contaminated our baler at all. A little bit there. Just got a little bit bottom here, and we will let that. Well, I should have some gloves on. Disinfectant. Pull that in. I might be contaminating that sample without some gloves on. Good. And that's the sampling and the baling.